Hi and welcome to Transformers. No, we're not discussing vehicle-changing robots today. Instead, we'll explore an innovative approach for speech recognition using transformer-based models. These models provide high accuracy by effectively modeling long-range dependencies and context, making them ideal for complex languages. Transformers can adapt to different accents, dialects, and noisy environments, enhancing their robustness in various transcription tasks. In this lesson, we'll explore Whisper by OpenAI, a state-of-the-art transformer-based model for speech-to-text transcription. It's pre-trained on vast speech data, making it highly effective for various situations. Whisper's extensive training enables it to handle various speech patterns and contexts, providing accurate transcriptions in challenging environments where simpler models might struggle. We'll use Whisper AI to transcribe the same audio file we previously processed through the Speech Recognition Library and Google Web Speech API, and see if we'll obtain better results. All right. Let's now use Whisper AI to see how it performs. In a new cell in Jupyter Notebook, I'll create a variable and name it Model. After the equal sign, I'll type Whisper dots followed by the load model function to load the Whisper model. In parentheses, I can specify different model versions depending on the requirements of the task at hand. These versions can be base, small, medium, or large. Here, larger models typically provide better performance at the cost of more computational resources. I'll choose base because this variant provides a good balance between performance and resource requirements. The base model is also one of the most widely used options, serving as a standard for many speech-to-text tasks. Alright, now let's transcribe the audio file with Whisper AI. In the next cell, we'll use Whisper's transcribe function to process our audio file. The path I'll indicate in the parentheses. Let's store the transcription in a variable called result. If you receive a user warning after executing the cell, don't worry. This warning indicates that your system doesn't have a compatible GPU or the necessary graphics card drivers installed so that the model will run on the CPU instead. While a GPU can significantly speed up the processing time, the model will still function correctly on a CPU with slightly slower performance. The result variable contains a dictionary containing information about the transcription process. For now, I'll access the value associated with the key text and store it in a separate variable, making it available for later use. Okay, let's execute. Beautiful, a great-looking text with punctuation. My name is still spelled a bit oddly, but that's not a major issue. The rest of the text seems accurate and well-formed, and the verb turn is in its proper past tense form, turned. Perfect. As we see, the key text holds the actual transcribed text of the audio file. But as mentioned, other keys also bring information about the file. For instance, the key language automatically detects the language used in the audio file. Let's try it out. English. Good. It got that right. What's left is to evaluate the transcript using the well-known metrics WER and CER. Copy and paste the text from above, substituting the variable containing the transcript. Then execute. Wow, these are much better results. The transcription is significantly more accurate than the previous one, with fewer word recognition errors and character placement. This improvement demonstrates the effectiveness of using Whisper AI for speech-to-text tasks. Excellent. But let's look at what happened behind the scenes. Number 1. Pre-processing. First, the audio is normalized, meaning the volume is adjusted for consistency, ensuring that quieter and louder parts of the recording are processed evenly. Next, the audio is converted into a MEL spectrogram using the MEL scale. As we previously said, the MEL scale spaces out frequencies in a way that reflects human hearing, focusing more on lower frequencies, which we are more sensitive to. Using the scale, the model captures audio in a way that better aligns with how we naturally perceive sound, which helps it more effectively identify patterns in speech. Number 2. Acoustic Modeling Encoder. After that, Whisper's transformer-based encoder analyzes the MEL spectrogram and converts it into a latent representation. This compressed audio version retains the key characteristics of the speech, such as phonemes. Although it doesn't look like the original waveform or spectrogram, the latent representation captures all the essential sound features the model needs to understand the speech content. Number 3. Language Modeling Decoder. Finally, Whisper uses its transformer decoder to convert the latent representation into text. The decoder uses context to determine which words make sense in the transcription. For example, in the sentence, "My name is Ivan and I am excited to have you as part of our learning community," the model understands the surrounding words and structures to generate the text. It knows that Ivan is a name, right? But it can sometimes make mistakes. In this case, the model incorrectly transcribed Ivan as Yvonne, likely because Yvonne is a more common name in its training data. The context helps the model produce most accurately transcriptions even with these rare errors. The model also uses context in sentences like, "I'm a sound engineer turned data scientist," where it knows engineer is more appropriate than a similar sounding word like energy. It also understands that considering the rest of the sentence, putting the verb turn in the past tense makes more sense. The decoder continually uses the relationship between words to ensure the transcription is logical within the flow of the sentence. Number 4. Post-processing. Finally, Whisper does some post-processing to clean up the transcription, including normalizing punctuation, capitalizing sentences, and handling special characters to make the text more readable. Alright everyone, with another essential tool for speech recognition now at our disposal, we can wrap up this lesson. In the next one, we'll learn how to transcribe multiple audio files simultaneously and save the results in a table, a crucial skill for working with real-world datasets. As always, thanks for watching.